Hi, today we're going to talk about balance and unbalanced forces. Let me get back up to the beginning here. And right here it says use this space to jot down notes and drawings that will help you remember important ideas from this lesson. Well, to introduce what balanced and unbalanced forces are, we're going to listen to a video. I would like you to jot down some notes right here in this area based off of what you've learned in the video.
Look at what happens when forces are unbalanced. Welcome to Moo Math and Science and Balanced and Unbalanced Forces. Newton's first law of motion states that an object at rest stays at rest, and an object in motion stays in motion with the same speed and in the same direction, unless acted upon by an unbalanced force. But how are balanced and unbalanced forces different? Balanced forces will cause no change in the speed of an object. Balanced forces acting on an object in opposite directions and in equal strength, as shown in the arrows below, do not cause a change in the speed of a moving object. Objects that are not moving will not start moving if acted on by balanced forces. Remember, forces have a magnitude and a direction. Unbalanced forces are not equal, and they cause the motion of an object to change. When two unbalanced forces are exerted in opposite directions, their combined force is equal to the difference between the two forces. The magnitude and direction of the net force affects the resulting motion. This combined force is exerted in the direction of the larger force. Let's take a look at some real-world examples. The forces acting on the red pool balls are balanced. The downward force of gravity is equal to the resistance force of the pool table. When the white ball strikes the red balls, the forces are now unbalanced and they move in the direction of the force. The forces are balanced on the weights. The downward force of gravity is equal to the resistance force of the yellow rack. The weights do not move. The weightlifter exerts an unbalanced force upward and the weights move in that direction. The forces on the tennis balls are equal. They are not moving. When the tennis balls are struck by an unbalanced force, it causes them to move. The resistance force of the car is balanced with the downward force of gravity. The car jack exerts an unbalanced force on the car upward, and the car moves in that direction. The car is at rest, and all forces are balanced. When the car that is moving strikes the car at rest, then the forces now are unbalanced, and the car moves in the direction of this force. If you'd like to know more about unbalanced or
All right, so that's our unbalanced forces. So you're going to take notes and tell me what you learned in a race format right here. Okay. Use race format for the video that you watched. And I'll put the link right here as well. Right here, you're going to take and you're going to drag the correct definition to the correct term. So you have balanced force, unbalanced force, and net force. You're going to read these three choices and drag them to the right one. The overall force acting on an object expressed in newtons. The two equal forces act on an object in opposite directions when unequal forces cause an object to move. Determine which statement below represents balanced force and which represents unbalanced force. Drag and drop the cards to the table on the right. Write a short explanation under each card explaining why forces are balanced and why they are unbalanced. So, one tug-of-war team pulls harder than the other. Would that be balanced or unbalanced? Two teams play tug-of-war. Each team is pulling with equal forces in opposite directions. Is that balanced or unbalanced? Then tell me why this represents balanced forces, because why? And why would this represent an unbalanced force, because why? Read each situation and decide if it's an example of a balanced force or an unbalanced force. Click on the label with your answer choice and drag it off to the side to see if you are correct. An airplane in flight is cruising at altitude. Would that be balanced or unbalanced? It would be balanced. So you would take and you would move your correct answer right here, and you see you get a correct answer. Okay? Through the past week of learning about Newton's laws, how have you been impacted by balanced and unbalanced forces? Use your experience in the past week and write and explain one example of a balanced force and an unbalanced force that you have experienced in the past week. Use this space to jot down notes and drawings that will help you remember important ideas from this lesson. Motion graphing notes. Use this space to jot down notes and drawings that will help you remember the important ideas from this lesson. Use the erase format for the video that you watch.
Forces affect the motion of an object, and how can a force diagram be related to a kinematic representation of a motion, like a dot diagram or a motion graph? Well, I'm Mr. H, and I have some answers for you. Forces are pushes or pulls that act upon an object as a result of its interaction with its surroundings. We represent forces by force diagrams. Each arrow represents a force. The length of the arrow is representative of the strength of the force, and the direction goes in the direction of the force. There is no limit on the number of forces you can place on a force diagram. When viewing a force diagram, it's important to distinguish between balanced and unbalanced forces. When oppositely directed forces are of equal strength, we say the forces are balanced. Balanced forces cause objects to keep on doing what they're doing. If at rest, they remain at rest. And if in motion, they continue in motion with the same speed and direction. Balanced forces never cause objects to accelerate. When you see this or that, you know the object has a constant velocity. It could be at rest and staying at rest, as represented by these kinematic representations, or it could be moving and continuing in motion with unchanging velocity, as represented by these representations. Without ever stating it, I've been describing Newton's first law of motion. Objects at rest stay at rest, and objects in motion continue in motion with the same speed and direction, provided all of the forces are balanced. But do be careful, because not everybody believes in Newton's first law of motion. Let me explain. Here's a force diagram with an up and down force. Can this object be moving to the right? Or what about this force diagram with equal strength forces in all directions? Can this object be moving to the right? The answer is yes. Each of these objects could be moving to the right or to the left. You can't tell which direction an object is moving from the forces that act upon it. You can only tell how it is moving. And when you see a balance of forces on a moving object, you know it will continue moving with a constant speed. There doesn't need to be a force to the right for it to move to the right. Once an object is in motion, it will continue in motion with the same speed and direction as long as the forces are balanced. Unbalanced forces cause a change in motion, an acceleration. These diagrams show unbalanced forces. Unbalanced forces occur when oppositely directed forces are of unequal strength. We say there's an unbalanced force or a net force. When there is an unbalanced force, there is an acceleration in the same direction as the unbalanced or net force. So object 1 accelerates to the right, object 2 to the left, object 3 upwards, and object 4 accelerates downwards. But do be careful, because to accelerate to the left doesn't mean to move to the left. Let me explain. Here's two dot diagrams, one for an object moving to the right and one for an object moving to the left. But both objects are accelerating to the right. When an object is moving to the left and getting slower, we describe its acceleration as being directed to the right. Both of these dot diagrams are consistent with more force to the right than to the left, as represented by the force diagrams. So these force diagrams are representative of a rightward acceleration and can be represented by any of these kinematic descriptions, since each description represents a rightward acceleration. Here's two more force diagrams. Notice that there is more force to the left than to the right. With an unbalanced force to the left, the object accelerates to the left. It could be moving to the left and speeding up, as represented by this dot diagram and these graphs. But it could also be moving to the right and slowing down. In each case, the object has a leftward acceleration. A leftward unbalanced force is always going to cause a leftward acceleration. Without stating it, I've been describing a portion of Newton's second law of motion. An unbalanced or net force causes an object to accelerate in the same direction as the net force. Once more, you need to be careful. Unbalanced forces don't cause objects to move in a given direction. Rather, they cause objects to accelerate in a given direction. Unbalanced forces cause objects to speed up or slow down. If there's more force against the motion than with the motion, the object slows down. But if there's more force with the motion than against the motion, the object will speed up. We can repeat these same ideas for vertical motion. When there's more down force than up force, the object accelerates downwards. It could be moving up and getting slower, or it could be moving down and getting faster. When there's more up force than down force, the object accelerates upwards. Just like horizontal situations, when there's an unbalanced force, the object always accelerates in the same direction as that unbalanced force. The relation between force and motion can be one of the most difficult concepts to grasp, and you need to give it some patient practice. You'll find some pretty awesome interactive exercises on our website that will help you to make sure that you got this. You'll find links to them in the description section of this video, so give one of them a try. Hey, I'm Mr. H, and thank you for watching.
All right.
How do forces affect?
So you will take and you will put a race format together and type your notes in right here. When you're done with that, you'll continue on to this. It says drag and drop the tags on the right to label the graph. The x-axis that should be labeled time and the y-axis that should be distance. Use the rotate tool to make the labels vertical. Use the text boxes in the shaded areas to number the x-axis 0 through 8 in equal increments. Then the y-axis 0 through 80 in equal increments. Some have been started for you. So you have 0, 10, 20, then this would be 30, 40, 50, 60, 70, 80. You would go through and count 1 through 8 on this right here. Practice graphing motion. Drag and drop the dots below the plot to the points found on the data table. When finished, describe the shape and the graph. 2 points have been done for you. So you have 0 and 0. Now you have 1 and 10. Now you need to do 2 and 20, 3 and 30, 4 and 40, 5 and 50, 6 and 60, 7 and 70, 8 and 80. And then you need to tell me what the shape is. In your own words, describe what the motion of the object shown in the graph is. Be sure to include time traveled and distance traveled in the velocity. Okay, so you need to tell me how long it took for it to travel all the way from the bottom to the top. You need to tell me what the distance was, and you also need to tell me the velocity. Remember, to find the velocity, you will find it by taking and dividing your numbers. Okay? And you need to do that 3 times. So you find 3 different points. 1, 2, and then 3 right here. In your own words, describe the motion of the student shown in the graph. Be sure to include time traveled, distance traveled, and the velocity. First, the motion of the student is, what motion did they take? Right here. The travel time was how long? The distance traveled was how long? So the velocity is what? And you're going to do that 3 different times. Motion of the student was what? What way was it this time? The travel time was, how long did it travel? Did the student travel? The distance traveled was, what's the distance at? And the velocity, what's the velocity? This number divided by this number. And then finally, the last motion was what? The travel time was what? The distance traveled was what? And the velocity is what? Motion of a line. Drag and drop the descriptions below its correct graph on the right. So you have your distance and your time, and it's going this way. An object moving at a constant speed. Okay? Object turned around and headed back in its original location. The object is accelerating and moving faster. The object is not moving. So, for example, let's do this one. We have from this corner up and then back down. So this object turned and headed back to its original location. So you would take and drag that over to the right box, like that. In your own words, describe the motion of the student shown in the graph. Be sure to include time traveled, distance traveled, and velocity. Match the graph to the situation it is describing. Click on the graph and drag it to the correct situation. For instance, we have sketch a graph that represents someone driving to McDonald's for lunch and eating for 15 minutes when driving home. Okay, so someone accelerating from a red light and then gets stopped by a train. Someone that's walking slowly and stops to get on a bike and then rides away quickly. So let's do an example. Let's do someone is walking slowly and stops to get on a bike and then rides away quickly. So someone is walking slowly and they move quickly on a bike. That would be this one. And our last slide for today is graphing practice. You're going to use the line tool to sketch areas sketch a series of motion graphs. Go to Insert Shape and choose a line option. You may have to add multiple lines to one graph to illustrate different directions or speed. So you're going to hit your plus button and you're going to draw a line and make a line graph for your distance and your speed. And that is all for today.